Okay, we're on lesson 53. This is solving problems using measures of central tendency. Your objective is here, don't forget to write it down. Okay, example 1. It says the owner of a cafe was interested in the age of her customers in order to plan marketing. One day she collected these data on customers' ages, and then we have our numbers right here. So she looks like she surveyed 10 customers and asked them their age. Okay, part A says to make a line plot of the data, and then find the mean, median, mode, and range. Okay, and it says which measure, mean, median, mode, or range, best represents the typical age of the customers. Okay, so our job is to find each one of those and then tell which one we think does the best job of representing our data that we have. Okay, which one would give the most accurate information if we reported it. Okay, so let's go to the next slide to go ahead and solve this problem. Okay, so I have put our data in order from smallest to largest here. Okay, so going across, we go from smallest and then we'll go all the way up to largest. Part A is done here. This is the line plot, okay? So you need to draw this out. So what a line plot is kind of like a number line. So we've got 20, 30, 40, 50, 60, 70, 80, and we're counting by 2's in between here. So this is 22, 24, 26, 28, and then 30, okay? And then all we do for a line plot is we put x's above the line plot where our data is. So this first x, okay, represents the number 27 because it's 22, 24, 26, or sorry, we're at 22, 24, 26, 28, and then right in the middle here would be 27. Okay, this next x is right over the line for 28, so that's our 28 data. Then age 31 is going to be right here in between 30 and 32, and so on. Okay, so this is what a line plot looks like. Now, the good thing about a line plot is we can kind of see how our data is located. Okay, so you notice here, most of our data is right here in between ages 27 and 42. Okay, so kind of middle-aged people. So we're right here. And then we got these couple people that are way out here. Okay, so again, the good thing about a line plot is it will help us view our data, so when we have to answer that part B, we'll be able to do that easier. Okay, so we need to, in part A, find the mean. Oops, sorry, I want my different pen again. Okay, so we got to find the mean, the median, the mode, and the range. Okay, well, I always like doing the range and the mode first because they're the easiest ones. So the range should be the highest minus the lowest. Okay, so 75 minus 27 will give us the range. Okay, and 75 minus 27 is 48. So that's our range. Okay, the one that the mode is the one that occurs the most. So we have to tell, do any of them occur more than any other number? And if we look at our line plot, there's no x's that are, or there's no spots that have two x's. Okay, so like if the number 38 had occurred more than once, there'd be another x above this one right here. So there's no mode in this case. And another good thing about a line plot is you can easily see where the mode is because you can see which one has the most x's over it. Okay, so the median, again, is the middle number. So we need to find the middle number. And to do that, we're going to cross off our data low to high until we get to the middle. And we've got two middle numbers, okay, 35 and 38. So to find that, we're going to take 35 plus 38. And then we're going to do that divided by 2. Okay, well, 35 plus 38 is 73. And 73 divided by 2 is 36.5. Okay, so our median is 36.5. Now for the mean, we are going to add up all the numbers and divide by how many there are. Okay, so we need to take them all and add them up. So I'm going to do that really fast on my calculator to save time. So we're going to do 27 plus 28 plus 31 plus 33 plus 35 plus 38 plus 41 plus 42 plus 73 plus 75. And and that gives us 423. And we're going to divide that by how many there are. Well, there are 10 of them. And 423 divided by 10 is 42.3. Alright? So we've got our mean, our median, our mode, and our range there. So part B is we're supposed to tell which one best represents our data. And again, this is why I like the line plot. Okay, because in our line plot, we can easily look and kind of see which one best represents our data. Well, if we look at the mean is 42.3. Okay, so that'd be way up here. So our mean is above most of our data. And the reason why the mean's higher than the rest of our data when it's the average is because we got these two out here that really skew it, okay? They kind of change it a little bit. They make it bigger than it should be, and these are called outliers. Okay, so these outliers really affect the mean. They make it higher than it really should be for an average. So our mean isn't the best because most of our data aren't around the mean. Okay, most of them are below it. Well, the median is 36.5. 36.5 is right here in the middle. Okay, right in this clump. So that would be a good representation of how old the people are. Okay, no mode, well, we obviously can't use that. And our range is 48, that's way out here too. Okay, so we're going to say that we're going to use the median to report the data because it's in the middle. It is closest to the middle. Okay, and in this case it's the best representation of the data. And again, normally a lot of times it's going to be the median or the mean, but this time the mean was out here where is above most of our data. Alright, let's go on to another example. Okay, example 2 says, suppose the median age of residents of a certain state was 30. 20 years later it was 37. What changes in the population may have occurred in the 20 years? Well, let's look at a really small set of data where the median would be 37, okay, so, or would be 30. So let's say the median is the middle number here. Okay, we want to keep that in the middle, so I'm going to put some numbers on both sides of it. 36, 37, 38, oops, 38. And over here, if we put 4 more numbers, we'll do 29, 28, 24, and 20. Okay? So here's an example set of data where the median would be 30 right now. Okay? So let's think of what changes would have to occur for it to be 37. Okay? Well, one change that could occur is all these young people down here could move out. Okay, if everybody below age 36 moved out, then the median would be 37. Okay, so one answer is young people could move away. Okay. Another possible answer is maybe we add more older people over here. So people older than 37 can move in. Okay, to make that true. So people older than 37 can move in. Okay, and those are two possible changes. Okay, so really one way to shift the median to a higher number would be to add more things above it. Okay, or to take away things below it. So that's one possible way for us to shift what the median is. If we want the median to be higher, we can take away lower numbers or add higher numbers to it. Alright, let's go on to another example. This one says, consider the salaries of the employees of a small business. In an interview, a prospective employee was told the average salary of the employees is $50,000. How might this information be misleading? Okay, so look at all our yearly salaries here. We got 32, 34, 32, 30, 37, 43, 45, 67, 85, and 95. And our mean is 50, our median is 42, our mode is 32, and our range is 65. And the people who were doing the interview they used the mean. Okay, they said that the average is $50,000, and they're not lying. Okay, because if you added up all the numbers and divided by how many there are, you would get 50,000. Okay, but look at all these numbers. Okay, look at 50,000 here, and we've got 32,000. 34,000, 32,000, 30, 37, 43, 45. Almost all the numbers are below 50,000. Okay? And we've got these three numbers up here that are higher, that are making it go up. Okay, so those could be like the maybe the CEOs, the people who are in charge, or the supervisors, things like that. And maybe all these are the normal employees. Okay, here's like somebody who's starting. Here's somebody who's worked there for a while. Okay, so this information is misleading because of the numbers at the top. So it is misleading because most of the salaries are below 50,000. Okay? And there are three salaries that make the mean higher. Okay, so really in this case, if we wanted to tell the employees what their salary would be probably to start with, okay, then we wouldn't even report the median because 40,000 is higher than most of them, but that would be a better number than the mean. Okay, the mode in this case would actually be closer to where they would probably start out. Okay, and let's go into one more example. Okay, it says Josiah sells 3 different hats to test their popularity. His sales are reported in the bar graph below. The height of each bar corresponds to the number of hats of that type Josiah sold. It says find the mode of the data, and why are we not interested in the mean or the median? Okay, well, Josiah is interested in the number he sold to tell which one's the most popular. Okay, so if we want to look for the most popular, we want the one that's sold the most. Alright, well, the one that's sold the most would be type 1 here. Okay, so the mode of the data is type 1. Okay, because type 1 has sold the most of them. Okay, and we're interested in the mode because we want the one that occurs the most here. He's interested to see which one's the most popular. He's not interested in the average of the number sold, okay, anything like that. So we're not interested in the mean or the median. Interested. Whoops, I should have left my room for that, sorry. Interested in mean or median because we are looking at the most popular. Which is the type that sold the most. Okay? So if it has something like what's most popular, we're going to look for the mode, which one occurred the most in that case. So we're not interested in the average. Okay, and that's your lesson on measures of central tendency. Good luck on the homework.